guys, today we are going to do section 3-3, Systems of Inequalities. So you will be able to solve a system of linear inequalities. Our big idea, you can solve a system of inequalities in more than one way. Graphing the solution is usually the most appropriate method. The solution is the set of all points that are solutions of each inequality in the system. So, an inequality and a system of inequalities can each have many solutions. A solution of a system of inequalities is a solution for each inequality in the system. You can solve a system of linear inequalities by graphing. So this is the method that we are going to use. Recall that when the variables of a linear inequality represent real numbers, a graphed solution consists of half a plane and possibly its boundary line. So that's when we picked a test point and shaded one half of our coordinate plane. So for two inequalities, the solution is going to be the overlap of the two half planes. Where both of our solutions overlap will be the solution to the system. So we are going to graph the two inequalities. Starting with the first one, we are going to rewrite 2x minus y is greater than or equal to -3 in slope-intercept form. So 2x minus y. I'm going to subtract 2x from both sides. And I'm going to divide by -1. So y is less than or equal to, because I divided by a negative, I need to flip my sign. 2x divided by -2x divided by -1 is 2x. -3 divided by -1 is +3. This is now in slope-intercept form. So I'm going to take my y-intercept of 3, plot it, and use my slope of 2 to make my line. So I'm going up 2 over 1, or I'm going down 2 to the left 1. I'm connecting my points with a solid line because in my original inequality, I have less than or equal to. Since it's or equal to, we have a solid line. In order to pick what side we are shading, we need to pick a test point. Normally we pick 0, 0. So is 0 less than or equal to 2 times 0 plus 3? That turns to 0. Is 0 less than or equal to 3? Yes. So I'm going to shade this side of my coordinate point. My second inequality is y is greater than or equal to -1/2 x plus 1. Since I'm already in slope-intercept form, I'm going to graph that starting at 1. And I'm going with my slope down 1 over 2. Or up 1 to the left 2. I'm also connecting these points with a solid line because it is, once again, or equal to. In order to figure out where I'm shading, I'm going to pick 0, 0. So is 0 greater than or equal to -1/2 times 0 plus 1? Is 0 greater than or equal to 1? No. So we're not going to shade the point where 0 is. We're going to shade the opposite side. Now, where the two graphs are overlapped is the solution to this system of inequalities. So, from our boundary lines and in between this system are the solutions to our system of inequalities. Okay. What is the solution of the system of inequalities if y is less than or equal to 3 and if y is greater than or equal to the absolute value of negative 1? So, our two inequalities in this system are not both lines. Our first inequality is y is less than or equal to 3, which is a horizontal line at y equals 3. So at y equals 3, I'm going to make a solid line because it's less than or equal to. And where are the values that are less than or equal to 3? Below. Then we have our second inequality, which is y is greater than or equal to the absolute value of x minus 1. This absolute value of x minus 1, when we're graphing the absolute value, we need to find our vertex. So our vertex is the opposite of C, D. Therefore, our vertex is 1, 0. So I'm going to make a point at 1, 0. Which I then know that my axis of symmetry is at x equals 1. Make a table of values. I'm going to go to the right, so I'm going to plug in x equals 2 and x equals 5, so that my graph is a little bit more spread out. And y is equal to the absolute value of 2 minus 1, which is equal to 1. And 5, the absolute value of 5 minus 1, which is equal to 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm going to reflect those on the other side. And since it's greater than or equal to, I'm going to connect with a solid line. I then need to figure out where to shade this absolute value. I'm going to pick a test point of 0, 0. So is 0 greater than or equal to the absolute value of 0 minus 1? Is 0 greater than or equal to 1? No, so I'm going to shade the opposite side, which would be inside my absolute value. And the overlap for these two would be this section inside my absolute value graph. That's it.